Our universe is filled with never-ending mysteries that date back to the beginning of time. One of those mysteries is how the universe came into being. For almost a century, scientists have put forward many theories to explain the creation of the universe, but only the Big Bang theory is regarded as the most reliable one. However, with the ever-improving technology, specifically the James Webb Space Telescope, there are rumors that the Big Bang theory might not be true. Watch the video till the end as we tell you why JWST never disproved the Big Bang and the theory still holds true. Big Bang and the JWST. Since the Big Bang theory was first presented by George Lemaitre in 1931, physicists and astronomers have worked to verify its veracity. On numerous occasions, astronomers have questioned the theory and sought to demonstrate its logical justification. When JWST was launched back on Christmas Day 2021, astronomers hoped that it would help clear their confusions and much more. The billion-dollar telescope was developed with the purpose of taking pictures with the help of infrared light. It is worth mentioning that infrared imaging is the ideal tool for capturing images of the first stars and galaxies that emerged shortly after the universe's creation. After a month-long voyage to its operational location, NASA engineers and scientists spent nearly 6 months commissioning the JWST and getting it ready to search the universe. Then finally, on July 12, 2022, JWST showed its capability as astronomers published numerous stunning photographs. The data from the images showed that the wavelengths of light from those old stars has been stretched by the expansion of the universe brought on by the Big Bang. These images sparked a rumor that the JWST has refuted the Big Bang theory. This happened with the discovery of galaxies that were billions of light years old. The images of galaxies JWST published would have formed within 100 million years of the Big Bang, which scientists thought was impossible because of the Dark Age. The Dark Age is a time during which no stars or galaxies were formed after the Big Bang. This period lasted for about 1 billion years, so the presence of these galaxies created massive doubts. However, many scientists have presented other possible explanations for this. They think these galaxies might have formed as a result of an incorrect redshift, intense radiation, or some unidentified forces that could have changed the shape of the light waves. Up until now, the astronomers have estimated the universe to be 13.7 billion years old. However, the actual number may be considerably older. Evidence of the Big Bang. The Big Bang idea is supported by two key pieces of evidence. First one is the universe is always expanding. However, this was not the case before the 20th century, as the universe was believed to be static and to have a finite constant volume. Then, in 1924, Edwin Hubble, who is now recognized as one of the finest astronomers of all time, found that galaxies farther from Earth had a farther, faster recessional velocity than those closer to us. In layman's terms, this meant that as the universe expanded outwards, distant galaxies were moving away from Earth far more quickly. You must be thinking that, how did Hubble come to this conclusion? The answer is simple: redshift. Redshift is a well-known astronomical phenomena that was crucial to Hubble's discovery of the universe's expansion. For instance, we experience redshift when a transmitter or object sends out waves that are stretched out. As distance is directly proportional to time, the farther away the object or transmitter, the more the waves we received will be redshift. This phenomenon helped Hubble demonstrate unequivocally that the universe is expanding. Astronomers also think that a force is rapidly tearing the cosmos apart and pushing galaxies apart and away from one another. They have termed this hypothesized force as the dark energy that acts in opposition to gravity by exerting a repellent negative pressure. The second important aspect that has caused scientists to believe that the Big Bang Theory is real is cosmic microwave background radiation. According to scientists, the CMB is a byproduct of the Big Bang or a shockwave from the Big Bang that produced this radiation. They have also demonstrated that there is no other explanation for why CMB might arise in our universe, as even extremely powerful events like supernovae and intergalactic collisions would not have the energy necessary to leave such a massive radiation wake. As the Big Bang model is only supported by these observations, we have built the Standard Model of Cosmology, also called the LCDM model, based on it. The validity of this standard model can be demonstrated by looking at its predictions for various observational tests. Having said that, a lot of these theories and models are based on the assumption that the universe is shaped like a sphere, which is a completely different area of inquiry in and of itself. While some contend that the universe is in fact spherical, other opposing theories propose that it is instead flat, seven-dimensional, torus-shaped, or even cubic in shape. As a result, the pursuit of the universe's genesis has always been one of the most fascinating and captivating subjects for cosmologists. The recent findings. Although the recent James Webb Space Telescope findings do not refute the theory of the Big Bang, they do show some peculiar and surprising aspects of the cosmos. JWST has discovered galaxies that are both further away and larger than they should be, which could result in some radical modifications to our standard model. Some of the newest galaxies that originated just after the Dark Ages can be seen by Webb because of its extreme sensitivity. These newborn galaxies should be less abundant and less evolved than later galaxies, yet the Webb studies have discovered a surprising number of extremely redshift young galaxies that are quite developed. It is worth mentioning here that the existence of distant galaxies is not always an issue. In reality, the contemporary version of the Big Bang hypothesis, known as CDM cosmology, where CDM is short for cold dark matter, anticipates the emergence of galaxies in the really early universe. That's because there were no galaxies or even stars billions of years ago. Everything was much more uniform, with only minuscule density deviations arising here and there at random when our universe was much smaller and denser than it is today. Yet, as time went on, the slightly denser pockets began to draw additional material onto them, increasing the density discrepancies. These pockets evolved over hundreds of millions of years into the first stars, which then expanded to become the first galaxies. Finding galaxies in the relatively young cosmos is not evidence against the Big Bang theory. Rather, it is one of the key goals of the Webb telescope to detect and study those first galaxies. So, is the Big Bang theory in trouble or not? Unsurprisingly, the answer is no, or at the very least, it is exceedingly unlikely. We will only know the answer to these questions for sure with the help of additional data and time. In these early studies, the hue of the light coming from early galaxies is determined using a straightforward procedure utilizing a number of optical filters. However, the JWST has more accurate spectrometers that will enable astronomers to determine the wavelengths of light emitted by these distant galaxies with greater accuracy. Consequently, the improved results will help address all these questions. All in all, this data has provided astronomers just what they were hoping from JWST. They are now continually looking for distant galaxies in order to track light coming from distant celestial objects that has already reached Earth and, eventually, determine when our universe began. The JWST has certainly lived up to their expectations in its first year of observations, and even though the Big Bang theory is still valid, it is wise to acknowledge that some of our presumptions might soon change in the coming years. That's it from today's video. We hope you enjoyed the content of the video. If you did, show some love and hit the like button, and don't forget to subscribe to our channel so that you never miss out on any of the amazing videos we have in store for you.